Today we're going to be learning number bases, but first the homework. The first question was, how many zeros does 1948 factorial end in? So in the chat, please type the answers you got on your homework. Okay, I see one answer in the chat. Can more people put the answer that they have for the first question of the homework in the chat? Okay, I see two answers. Can one more person put their answer in the chat? Okay, so more answer. So the number of zeros is determined by how many times you can divide it by 5. So how many times you can divide it by 10. So when you divide by 10, that's the same as dividing by 2. 5. That's the same as looking for how many 2 times 5s there are. And we should be looking for the number of 5s because the number of 5s is less common than, because 5s are less common than 2s. So the rule for finding the number of 5s in x factorial was explained in the presentation previously. So we find x divided by 5 plus x divided by 5 squared rounded down plus x divided by 5 cubed, and so on until you round down to 0 for one of the numbers. So we'd get 948 divided by 5, which is approximately 389. Then 948 divided by 25, which is approximately 77. We'd get 948 divided by 125, which is approximately 15. And 948 divided by 625, which is approximately 3. And we stop there because 1948 is smaller than 3,125, which is 5 to the power of 4. So we get 389 plus 77 plus 15 plus 3, which is 484 trailing zeros. Okay, problem 2 was find the greatest power of 2 that fits into 1829 factorial. So in the chat, please type the answers you got. Okay, so I see one answer, 2 answers, 3 answers. Anyone else want to put their answer in the chat? Okay. So the number of times a prime number of a appears in the prime factorization of x factorial follows this general rule. So you round each quotient down to an integer. So you round x divided by a to an integer, x divided by a squared, x divided by a cubed, and so on until one of the values rounds down to 0. So we do that, but with 2 instead of a. So 1829 divided by 2 plus 1829 divided by 2 squared plus 1829 divided by 2 cubed, and so on until 2 to the power of 10 is 914. It rounds to 914 plus 457 plus 228 plus 114 plus 57 plus 28 plus 14 plus 7 plus 3 plus 1, which is 1,823 twos in the prime factorization of 1,829 factorial. So I saw that 3 people got it correct in the chat. However, there were many people who got it wrong on the homework. So make sure you know why you got it wrong. And yeah. So the answer would be 2 to the power of 1,823. So what is the last digit of 1,229 to the power of 8,992? Sorry. Oh God. So in the chat, okay, I see many people have put their answer as 1. So first we list out the powers of 1,229 and find a pattern in the units digit. When raised to an odd power, it ends in 9. When raised to an even power, it ends in 1. So that means that so we can see this in the pattern shown. So we fit 8,992 into the pattern. 8,992 is even, and even powers must end in 1. So the answer is 1. And then problem 4. What is the sum of the last 2 digits in 1,229 to the power of 8,992? So in the chat, please type your answers. So I'm seeing lots of 5s. And that's the correct answer. However, I saw many people had gotten it incorrect in the homework. So the pattern of the last two digits is 29, 41, 89, 81, 49, 21, 9, 61, 69, and 1, right? And this repeats, this pattern of two digits repeats every 10 numbers, right? So what we have to do is 8,992 mod 10, which is equal to 2. So that means we find the second number in the pattern, and that will be the last two digits, right? And the second number in the pattern is 41. 4 plus 1 is 5. So the sum of the last two digits in 1,229 to the power of 8,992 is 5. Okay. And then for the fifth problem, find the sum of the values in the 18th row of Pascal's triangle if the top row is the 0th row. So we didn't exactly get to cover this in class. However, if you looked at the slides, you would have known how to do this. So I'm saying 262,144. So the rule of Pascal's triangle is that the nth row is 2 to the power of n, like the sum of the values. So we're looking for the sum of the values in the 18th row, and 2 to the power of 18 is 262,144. So that means you guys are correct.
And also the Pascal's triangle can be used for like a number. It has a number of uses. So especially when if you guys take like the counting class, you'll notice that the Pascal's triangle will be very useful. So just, remember what this is, because it is very helpful in like other math topics as well.
Yeah, and also a number of you guys got like different problems incorrect, like many problems incorrect. So like the average score was a 2 on this. So in the chat, can you please just type why you got like some of them incorrect, like whether it's because of silly mistakes or you didn't understand the content, or you just needed more practice, or what. So you can private message me or Rashab, or you can put it in the public chat, but please just tell us why you think you got it wrong, or if you know why you got it wrong, can you say why you got it wrong? Because the key to like learning from this, the key to like growing from this is to know why you made the mistake, so you don't make them again, or if you make them again, you'll know how to not do it, again. Okay, so many people are saying that they added incorrectly or they calculated it incorrectly, while other people misinterpreted the questions. So if you misinterpret the questions, so make sure, like, although, like, for example, I saw like 2 people misinterpreted one question, like the sum of the last 2 digits to be the sum of like the last digit of one number and the sum of the last digit of the number before. And then they got 10 because 9 plus 1 is 10, right? However, that was asking for the sum of the last 2 digits of that number specifically. So make sure, like, when reading a question, what you are thinking the question is asking for is logical for the question to ask, given the information.
And also, if you put like you miscalculated in the chat, or if you put something like you misinterpreted the question, on today's homework and upcoming homework assignments, try to not make those same mistakes again, because that's the only way you're going to get better. So be more careful that you don't repeat the mistake that you made.
Right.
Yesterday.
And if your addition is off, or like your math was off, but like your actual work was correct, make sure that you double check your work, because like right now when you're doing the homework or when you're in class, you don't really have a time constraint for the problems. You can do it at your own pace, right? So take advantage of that and check your answers, check your problems, right? So you do not make those silly mistakes, and eventually that checking part will not take as much time. So you could potentially do that on an exam, like on the AMC or on math counts or something. So yeah.
Okay, so now we're going to talk about the base and number system. So this is a little bit of a confusing topic, but it is very important to know about. So this is the number system that we are most familiar with, and as are you guys. It's the base 10 number system, which is the number system we use in our everyday lives. So of course, 10 to the fifth is the hundred thousands, 10 to the fourth is 10,000s, 10 cubed is thousands, 10 squared is hundreds, 10 to the first is tens, and 10 to the zero is ones. So if we want to write a number as 540,675, we can write it in terms of these values. We can do, 10 to the 5 times 5, plus 10 to the 4 times 4, plus 10 squared times whatever it was. So this is the base n number system that we use in our everyday lives. And if we want to do other base number systems, it's a very similar concept. It's just you're doing it. If you replace the 10 with like a 7, then you get another value. So now we're going to look at an example. So we have 783. So this is in base 10. It's you can just write it out 700 plus 80 plus 3 because we have the hundreds place, tens place, and ones place. So the reason it's hundreds, tens, and ones is because in base 10, it's 10 to the 0 is 1, 10 to the 1 is 10, and 10 squared is 100. As we move on to other number bases, instead it'll be, if we're doing like base 2, it'll be like 1, 4, and 8 instead of 1, 10, and 100. Okay, so this is what I was talking about. So if we're doing any other base number system, then it's instead of being 10 to the 5 or whatever it may be, it's just going to be whatever base number you're doing and the exponents of that. So like binary or base 2 would be 0, 1, 4, 8, 16, 32. One thing you want to remember is that when you have like the last digit of the number, instead of being n to the 1, it's always going to be n to the 0. So just keep note of that.
Yeah, and any number to the power of 0 is 1. So the right hand number place will always be the ones place. And you should just remember that. And also a thing to remember when you're converting between number bases, if there's no value for say like n to the 4, you wouldn't do for example, if in base n it was 1, 0, 1, 2, 3, 4, right? You wouldn't just skip out that 0, right? You would keep that 0 there because it represents that n to the 4 has nothing, right? So make sure that you do not skip on the 0.
Okay, so this is an example of a binary number system. One thing that is critical for binary number system, and binary is the most common number system, not only in math, but it's used in a bunch of other real world applications, like a lot of importance in computer science and data representation. One thing you always want to know is that if you're using base 2, your limit is only until 1. So the only 2 digits you're going to use are 0 and 1. And it's similar for the rest of the number bases. Like for example, if you're doing base 10, you can't use 10 as one of your digits, okay? It only goes until 9. If you're doing base 5, the only digits you can use 0, 1, 2, 3, 4. If you're using base 7, you can do 0 through 6. So if you're trying to write a number in base 3, if you have like 5 as one of your digits, you know you did something wrong because that's like impossible.
Right. So a question for everyone. So how would you represent the number that's on the screen in base 10? So using the place values, try to represent it in base 10.
Yeah, so first compute the value, like to express this in base 10, just compute the value of this. That's all you need to do to find the base.
What you do is you multiply the place, like the place value, by the value that's in the place, right? Okay. So here you do 2 to the power of 3 times 1. And if there was a 1 somewhere else, then you like say in the 2 to the power of 1's place, you'd get you'd do 2 to the power of 1 times 1 if there was a 1 here. So make sure that
exactly what you would do in base 10. So just do that for base 2, and then you're going to get your base 10 value. If you have any questions, ask in the chat. This can get a little bit confusing.
Yeah. Also make sure that you are participating. Like you might get the answer and then not put it in the chat, but we don't know if you've actually done, like if you've actually tried to do the problem. So please make sure you do put it in the chat. I see 2 answers. One of them is correct.
I've gotten the correct answer as well. So I'm just gonna go over how to do this. So this one's pretty trivial. It's just 2 to the 3rd times 1. That's all you're doing here. The rest have 0, so you're not multiplying anything. You're just doing 2 to the 3rd times 1. And let's suppose if it was 0, 0, 1, 0, 1, 0, then you would do 2 to the 3rd times 1 plus 2 to the 1 times 1, and then you would add the results. So that's all you're doing here. You're doing exactly what you do if this was base 10. So that's essentially the concept. Yeah, so it's 8.
I didn't understand what you said.
Okay, let me.
So wait, can I explain?
Yeah, you just write on it. That'd be easier.
Okay, so so for example, let's take another number, like not this one. Okay, let's say it's 1010 in base 2, right? So the place units would be 2 to the 3rd. So this is the 2 to the 3rd place. This is 2 to the 2nd place. This is 2 to the 1st place. And this is 2 to the 0th place. So the 2 to the 3rd place is the 8th place, basically. So you multiply the place, like the value of the place number, by the actual number that's in it. So we do 8 times 1 for this, and that would be equal to 8, right? And then for this,
how do you know it's the 8th place?
Because it's the 4th from the right. So
the right is always 2 cubed. So when you move over, it's 2 cubed, 2 to the 1st, 2 squared, 2 cubed.
No, sorry. The right is always 2 to the 0. And
yeah,
then
sorry. The right is always 2 to the 0. And so it's exactly how it is in tens. In tens, it's 10 to the 0, 10 to the 1.
Oh, I get it now.
Yeah, so it's essentially what you would do if you were doing it in base 10.
2 to the 4th would be 16.
Yeah.
Yeah.
Mhm.
So
wait, so how did you get 8? I still don't understand that.
2 to the power of 3 is 2 times 2 times 2. And 2 times 2 times 2 is equal to 8. So 8 times 1, which is the value that is in this place, is 8. So we get 8 for this place value.
I just didn't get how the exponents and the number are connected. No,
Okay. Wait, I think it would be easier if okay. Ishani, wait 1 second. I think it'd be easier if I wait 1 second. I'm gonna open like a Jamboard and write it out because I think that'd be easier to explain. I think some people are confused. So
Are you converting it to base 10?
yeah, that's what we're doing right now.
Okay.
That was the question. Okay, wait 1 second.
Okay, in the chat.
Yeah, I'm gonna private message you and then you can screen share it. So
Yeah. Can everyone
get it?
see? Can everyone see the Jamboard?
Yeah.
You're okay. Yeah, okay. So so right now we're working on base 2, but let's take an example of base.
No, let's just do base 2 first. So
yeah, so we'll just do base 2. I was gonna do an example of base 10 just so that it would be easier to explain. So if we take the number 1, 2, 3, and 4, base 10. So right now we're just doing 1. So this is the thousands place. Like this is the thousands place. This is the hundreds place. This is the tens place. This is the ones place. So what are we doing here? We're doing 10 cubed times 1. So that's just 10 cubed. And then we're doing 10 squared times 2. And then we're doing, so we're doing 10 squared times 2. And then we're doing 10 times 3.
And remember, it's 10 because it's 10 to the power of 1, but that power of 1 just means.
And then we're doing just 10 to the 0 times 4, which is just 1 times 4. So that's just 4. Right? So then when we add these up, we get 1000 plus 200 plus 30 plus 4, which is this number right here, the number that we were looking at, this number right here, right? 1, 2, 3, 4. So right now what we're doing is we're doing the same thing for a binary number. So I'm going to take another example of a binary number. If we have 1, 0, 1, 1. So I'll draw a line. So this right here, this is 2 to the 0, right? It's the 2 to the 0th place. Instead of, yeah, so it's just the 1's place. This right here, instead of being the 10's place, it's the 2's place, like it's just 2, right? This, instead of being the 100's place, it's the 4th's place, because we're doing 2 squared. And then this last number, instead of being the 1000's place, it's the 8th place, so 2 cubed. Same thing as what we're doing in base 10. So then when we try to solve for this, we're doing 1 times 2 cubed, so that's 8, plus 1 times 2 to the 1, so that's 2. And then we're doing 1 times 2 to the 0, and that's just 1 times 1, so 1. So when we take this number right here, when we take this number and we convert it to base 10, we're just doing 8 plus 2 plus 1, and that equals 11, right? Hopefully that should clarify what we're trying to do. If you guys need another example, I can do another one, but does everybody understand what I'm saying now?
I think so. However, I got a question in the chat. Is the answer to original problem 8 or 8,000? The answer would be 8 because the number that was in the 2 cubes place was 1. Let me pull it up. Okay, the answer that was in the number that was in the 2 cubes place, so this was 1. So that means that we do 2 cubed times 1, not 2 cubed times 1,000, because including 1,000 would make it a different base. If anyone at any time has any questions on how to do this, just unmute and ask. So yeah, wait for this to load. Sorry, my computer is slow. Okay, wait a moment.
Try stop sharing your screen and then opening it and then sharing your screen. That'd be easier.
Yeah, probably. Okay. Okay. So I think we have a Jamboard to do like right now. So if anyone has any questions, then like ask them. And if you do not have any questions, then say something in the chat saying you do not have any questions. Okay. Okay, it's still being slow. Yeah. In the chat, I will put the link to the Jamboard, because that's, yeah. Or, yeah, okay. Rashad put the link in the Jamboard, the link to the Jamboard in the chat. So in the Jamboard are questions. Like there are problems for you to solve. So make sure that you do them, like right now.
Everybody choose your own slide. So there should be enough slides. So everybody just open a Post-it note, put your name on the corner of the slide, and then that'll be your slide to work on. So everybody should get their own slide. We have like 18, so that should be enough.
Right.
All right, so I see Anand chose his own slide. So, okay, so.
Okay, let me just, okay, in the chat, there is a link to a Jamboard. So everyone choose your own slide. Skip this first page because we will be using it to review the answers. So basically on the left, it shows the number in decimal. On the right, it shows a blank, which
Oh,
is,
decimal is just base 10.
yeah. Okay, that's okay if your internet is a bit laggy. So basically, choose your own slide. Okay.
How do we convert from decimal to binary? I'm not a computer.
So basically, okay, so decimal, so basically you still take those same number bases. So for example, so because it's it's because it's binary, we would write out the, okay, we would write out the number bases, right, like how we did earlier. So we would have, okay, this is not gonna write. Let me annotate quick. Okay, so we would have 2 to the power of 0 as one base, right, as the rightmost base. Then 2 to the power of 1, then 2 to the power of 2, right? So we take the greatest number, the greatest power of 2 that fits into a number. So for example, say we're taking 200, or say we're taking 180, right? So the greatest power of 2 that fits into that, or actually let's take a smaller number, 45, okay? So the greatest power of 2 that fits into 45 is 2 to the power of 5, or 32, right? So let me just write this out. Okay. Sorry. So 2 to the power of 5 is the greatest power that fits into 45. So we put a 1 there. Now we subtract 2 to the power of 5 from 45, and we'd get 45 minus 32. So 45 minus 32 is equal to 13, right? So this place value over here is 2 to the power of 4, or 16. However, 16 is greater than 13, so we will put a 0 there. This place value over here is 8, right? 2 to the power of 3, or 8. And 8 is less than 13, so we put a 1 here. Now we subtract that 8 from 13, and we get 5. So over here we see that this place value is 2 squared, or 4, and 4 is less than 5, so we put a 1 here, because 2 to the power of 2 fits into 5, right? So now we subtract 2 squared from 5, and we get 1. So over here we have the 2 to the power of 1's place, and 2 is greater than 1, so we put a 0 here, because 2 to the power of 1's will fit into 1. And then over here, this is the 1's place. And because we have 1 remaining, that means we put a 1 here. And that means our number is 101101 base 2.
I didn't understand that at all.
Okay. Okay, so wait.
Should I explain it?
Yeah, sure.
Okay. Go back to the open Jamboard.
Okay, let me.
The one that I was the one that I was explaining on.
Yeah. Okay, it's on there now.
Okay, so as I did before.
Wait, firstly, I have a question in the chat asking, are binary numbers only base 2? Yes, binary numbers, binary equates to base 2. Binary is just another name for base 2, like how decimal is just another name for base 10.
Yeah.
So yeah.
So we're trying to convert like a number x, and we're trying to write it as binary. So I'm going to do, as I did last time, the same thing, but for base 10. So if we have the number, as 2, 5, 6. So in base 10, again, this is.
You might want to use a smaller example, just so.
No, I'm doing this so I'm doing this for base 10. So in base 10, what are we just gonna write this out? We're gonna write this out as 10 squared times 2, plus 5 times 10 plus 6, right? And essentially, we're doing the same thing for this number, but instead of writing it in terms of 10 squared, 10, and 1. We're going to write it in terms of 4, 2, and 1. Okay. So if I take a number, let's say 37. Okay. And we're gonna try to write this out in terms of powers of 2. So I'm gonna write it out, like draw our digit. No, that one's way too big. Okay. All right. So these are our placeholders. So first, okay, so Anand, I want you to tell me, what's the largest power of 2 that fits into 37? What's the biggest one?
5.
Yeah, so 2 to the 5th, right?
Yeah.
So 2 cubed, 2 to the 4th, no, 2 to the 4th. And then this one's going to be 2 to the 5th, all right? Okay, 2 to the 5th. So we have 1 of 2 to the 5th. So right now, so far, we have 1 times 32, correct? Do you understand so far?
Yeah.
And so what do we have left over? If we do 37 minus 32, what do we have left over?
5.
5, right? So now we have 5. So what's the largest power of 2 that fits into 5?
2.
Yeah, 2 squared, right? So these 2 to the 4th and 2 cubed are going to be 0 because they don't fit into 5. So it's just 2 to the 4 times 0 plus 2 cubed times 0, correct?
Okay.
And then we have 1 of 2 squared. So now we have plus 4 times 1. Okay?
Okay.
So now what's 5 minus 2 squared?
1.
So now we have 1 left over, okay? Because we already did the 32, we already did the 4. So now we have 37 minus the 32 plus 4. Now we have 1 left over. And the largest power of 2 to the 0 that fits into 1, the largest power of 2 that fits into 1 is just 2 to the 0, right? Because 2 to the 0 equals 1. So we have 1 of this, and then we fill this with 0, right? So when we write 37 as base 2, it's just going to be 1 times 32 plus 4 times 1 plus 1 times 1, right? And so when we write this out in our placeholders, it's 100101. And if you convert this number back into binary, and if you convert this number back into decimal, you're going to get 37 if you like add it out, right? So
Got it.
just so 32 plus 4 plus 1. All right, do you understand that?
Yeah.
Okay.
Does anyone else have any questions about number bases? Make sure you're actually like doing the problems. Like as
Why don't you open up another page on the Jamboard so I can show my work?
you can you don't need to show your work.
You can just use a piece of paper.
Okay.
And I don't know if my internet is like bad or something, and nothing is loading, or if people are not doing the actual
No,
problem.
there's stuff loading.
I mean,
There's definitely stuff loading. Not for everyone, but I do see a lot of answers.
I see a lot of people have gotten like far with it, and some people, and some people are not very far with what they are doing. So yeah, make sure you're working on it. Okay, it's fine if you're on the Jamboard through your phone.
Make sure to have it on the side.
Yeah. And there are enough slides for everyone, so yeah, just it should not be a problem. I see that there are multiple people on certain slides. So if two people are using the same slides, please everyone has put their name on a slide. So please make sure you aren't writing on someone else's slide. And because people are not showing work, you aren't supposed to show your work on the Jamboard, please do not just copy others. Some people are just getting started or have not started. If you have not started, please make sure you're working on the problems. Okay, so I see that some people have not completed the left column, they're just starting on the right column, and that's okay. But the left column is significantly easier because the numbers are smaller. So yeah, you should probably, if you have not done the left column, it'll be easier for you to do them. So yeah. And if it helps, draw out the number base thing. So draw out a diagram that shows the number bases. The rightmost would be 2 to the power of 0. Then the second rightmost would be 2 to the power of 1, and then 2 to the power of 3, and so on. So if that helps you, use that. If that helps you visualize, or not visualize, but keep track of your stuff, feel free to do it.
But as time goes on, you'll kind of it'll become second nature to the point where you won't have to write it out. I mean, you can probably, after you do a lot of these, you'll probably just be able to look at a number and say what the form is in binary. But again, those skills only come with
Practice.
lots of practice. and knowing your powers very well. That is something you should know.
Wait, so if you're trying to convert like 3 from decimal to binary, like how are you supposed to do that? Because 2 to the power 0 is 1,
So
right?
so 2 to the power of 1 is 2. So how many 2's go into 3?
Oh,
Yeah.
okay.
So yeah, you do it like that. So whenever you're doing this, you do not start from the right, but from the left. So you start with the greatest power.
You start with the
of 2.
largest power that
Yeah.
fit. And this is only binary. That's what you do for every number base. So if we like talk about another number base, don't get confused. It's exactly the same. Like, you know how binary and decimal are like essentially the same? That's how it is for every other number base.
Okay.
Except the numbers that you can use in other bases change.
Yeah,
So,
but the fundamental concept is the same.
right. So yeah, if it helps you again, write out like the base, like the place values of the base, you know, so it's easy to keep track of your work. And yeah. So at 10:13, I'm going to start explaining because a few minutes ago I saw like many people were almost done. So yeah. So it's okay if you're not like close to done, like if you're halfway done, or like as long as you're doing it, like as long as you're working on it, you know, that's good. And also this Jamboard will be like available to you even after this class, although like it might get erased. So like your work might get erased from it, but like if you do not finish, you can still look back at it and try to finish the problems that, or like work on the problems that you struggled with. So
Yeah, and it's fine if you don't finish. There's 20 questions, so
right.
it could take some time.
Mhm.
Good job to the people that have finished. I'm seeing a couple of charts that are completely finished.
And
okay.
if you're done, check your work because like it's very easy to make a mistake.
Also, I've seen this mistake on a couple of slides. Keep in mind, binary numbers can only be written in terms of 1 and 0.
Right. Like
Your answer should not have a 2. Like in any of your answers, there shouldn't be a 2. Having a 2 as a digit in binary is like having a 10 as a digit in decimal. You can't have 10 as a digit. It's not possible, right? It's only 0 through 9. So make sure your answer doesn't have any 2's.
Right. 10 is like 2 digits. Like it uses 2 digits to be written out. So like similarly, a 2 would require 2 digits, 1 and 0, to be written out. So yeah, make sure that you remember that. Like keep that in mind, that if you're in base n, the greatest number that you can have in your representation of a number is n minus 1. And yeah, so you should not be getting greater numbers.
If you ever get confused, just think about base 10, because you can connect base 10 to base, any other base.
Right.
And you guys know, you guys are pretty familiar with base 10, so
Right.
I think we should review it now.
Yeah, it's 10:14, so we'll review it. So I can do the left column and you can do the right one.
Yeah, sure.
Okay, so decimal, so 1 in decimal would also be 1 in binary, because the greatest power of 2 that can fit into 2 to the power of the greatest power of 2 that can fit into 1 is 2 to the power of 0. So that means that we just have a 1 in this place. And then 2 to the so 2 in decimal, the greatest power of 2 that fits into 2 in decimal is 1, or is 2 to the power of 1. So we'd put a 1 in the 2 to the power of 1's place, and then we'd put a 0 in the 2 to the power of 0's place, because 2 minus 2 to the power of 1 is just 0. So we'd have a 0 in 2 to the power of 0's place. And then for 3, the greatest power of 2 that can fit into that is 2 to the power of 2. 2 to the power of 1, where 2 to the power of 1 is equal to 2, right? So 3 minus 2 is equal to 1, and 2 to the power of 0, which is just 1, is the greatest. There is one of those that fits into 3 minus 2. So we have 11, or 1, 1, for the binary representation of that. Then for 4, the greatest power of 2 that fits into that. Oh, sorry, I forgot 2 to the power of 2, please. Okay, but the greatest power of 2 that fits into 2 to the power, that fits into 4 is 2 to the power of 2. And then 4 minus 2 to the power of 2 is just equal to 0. So we have zeros for the other digits after that. And then for 5, the greatest power again that fits into it is 2 to the power of 2. So you put a 1, and then since there's 1 left, after you subtract 4 from 5, you have 0 and then 1 again, because 2 to the power of 0 is 1. Then for 7, the greatest power of 2 that fits into it is 2 to the power of 3, or sorry, 2 to the power of 2, which is 1. And then 2 to the power of, so 7 minus 2 to the power of 2 is equal to 4, is equal to 3, because 7 minus 4 is equal to 3. And then 2 to the power of 1 fits into that, so we have another 1. And then we have 1 remaining, so we put a 1 in the 2 to the power of 0's place. Then 8, the greatest power of 2 that fits into that is 2 to the power of 3. And then there's nothing remaining after that, so we put the rest of the numbers as 0. So 1, 0, 0, 0. And then 9 has the greatest power of 2 that fits into that is 2 to the power of 3. And now we have a 1 remaining when we subtract 2 to the power of 3 from that. So we put a 1 in the 2 to the power of 0's place. And we get 1, 0, 0, 1. And then for 10, again, the greatest power that fits into it is 2 to the power of 3. So we have 1, and then 10 minus 2 to the power of 3 is 2. So then we have a 0 in the 2 to the power of 2's place because a 4 can't fit into 2. And then we have a 1 in the 2 to the power of 2's place, and 2 minus 2 to the power of 1 is 0. So then we have a 0 for the last digit. Yeah, I went through that kind of quickly. So if you guys have any questions about that, in the chat or unmute and ask your question.
Okay, so I'm going to explain the other column. All right. Okay, so when we're expressing that 17 in binary, we should be able to quickly realize that 17 equals 16 plus 1, both of which are powers of 2. So that would just be, I believe that would be 1, 0, 0, 1. So 16 plus 1, so 1, 0, 0, 1. Okay, so binary 1, 0, 0, 1, 0. So that is 16 plus 2. So that would just be 18, right? So 16 plus 2, so that's just 18. All right, now we're going to take a look at 25. So 25 is 16 plus 8 plus 1. So that's just going to be 1, 1, 0, 0, 1, I think. 1, 1, 0, 0, 1. So yeah, 16, 8, 4, 2, 1. Yeah. 1, 1, 1, 0, 1. So 1, 1, 1, 0, 1. So that's 16 plus 8 plus 4 plus 1. So that's just 29.
Wait, for the second row on the column, that's 18, right?
Yeah, that's 18. Sorry, my handwriting is not very good. Okay, so 29. Okay, 1, 1. Oh, this one's a big one. 1, 1, 0, 0, 0, 1, 0. Okay, so that is 1, 1, 0. Okay, that's 64 plus 32 plus 2. Yeah, so that's going to be 98. So exactly like literally all we're doing here is we're just taking the number, the power, whatever power it is, and we're just adding them all up. You don't have to focus as much about doing 1 times whatever it is, just because it's just the power, right? Like that's all we have to focus about. It's like 1 times a number is just a number. So now we're gonna do 128.
There's a text option in there, so you could just click on the box and they can just type.
Yeah, I know, but yeah, actually I should do that. Okay, so 128. So that's just a power of 2. It's 2 to the 7th. So it's just going to be 1, 2, 3, 4, 5, 6. I think that's how many zeros there should be. 1, 2, 3, 4, 5, 6. I think there's one more. Yeah, that should be right.
Yeah.
Okay.
And remember again, 128 is 2 to the power 7. So that's why we have 7 zeros, because 2 to the power 6 to 2 to the power 0 has zeros in it.
All right, wait 1 second, Sean. Sorry, wait 1 second. Okay, so which one are we on now?
We're on 10110110.
Okay, sorry. Yeah, my laptop glitched for a second. So 10110100. So we're just gonna do the same thing as we did last time. So I think that would be 128 plus 32 plus 16 plus 4. So that would be 180. Right? And if I'm correct, that's 180. Okay, so I'm just gonna write that out. Oh, all right, 180. 180. Okay, 200. So 200 is gonna be 126 plus 64 plus 8. So that's 11001000. 11001. All right, that should be correct. All right, 256, this one's pretty trivial. 256 is just 2 to the 8th, so it should be 1. I think that's the right number of zeros. Yeah, make sure you get the right number of zeros. That can be a little tricky. All right, so these answers are correct, I believe. And does anybody have any questions on how I answered these? I did these pretty fast at like a natural rate, just going off of, you know, mental
Right,
math.
and again, because like you all may, like, this might be a new concept for all of you, so you will probably be slower than us when you start. So because we went through this rather quickly, then like please ask. You might have like some like misconceptions or like misunderstandings, or you might just want us to explain something again, and that's okay, because like we might have gone a bit too fast. So yeah. If anyone has any questions, please type them in the chat. And if not, oh, okay, I can present. Okay. If this will load. Okay. Rishab.
Yeah, so this is essentially what we've been doing this entire time. It's just we're okay. Wait. Yeah, so we just have, you know, all of our places. It's the same thing as base 10. So this should be familiar. You should be familiar with this by now, because it's been, well, it's
Right.
what we've been doing all this time.
And also, like, if this helps you to write it out like this and then put the numbers where they go, do that, because like anything that helps you is fine. Like, no one's going to be looking at your work when you're getting the answer correct. So, yeah. So how do you express the value of 2 in binary using only ones and zeros? You do 2 to the power of 1, which is 0, 0, 0, 1, 0. Yeah.
By this point, if I give you like a random number, you should be able to understand how to express it in binary. And if I give you a random number in binary, you should be able to know how to express it in decimal.
And just because you should be able to know it doesn't mean you have to know how to do it quickly, because again, this is probably new to all of you. So yeah. But you should be able to know how to do it. So again, for all bases, we can only use 0 up till the value that is 1 less than the base number. And so yeah, for base 10, it's 0 to 9. So trick question, what's the highest number you can count to just using your fingers? So in the chat, type.
Wait, like, can we restart our fingers or not?
What?
Like, count to 10. And, like, if we count to 10 and then we
No,
go back.
no, you can't.
then-
You can't restart your fingers. So yeah, in the chat, type. So I'm not seeing anything in the chat. That just might be my computer.
That's just your computer.
Okay, yeah, it's not opening the chat, so there's that. Okay. Okay, can you like read out the answers that people have given?
28 infinity forever, 3 question marks and a backward slash.
Oh, okay. I see a 6 also, like direct message. Okay, so a lot of people think infinite, or they think like some random number. So actually it's only 1023. So basically you normally count like 1, 2, 3, 4,
This
5,
is a good question.
so on and so forth, right? But then like you can count, so pretend each number is like for base 2, right? So so this would be like, okay, does this show on the left of your screen, or does it show on the right?
Yeah, you can see it. You can see it.
Okay, so this would be 2 to the power of 9's place, 2 to the power of 8, 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. So basically when you put your finger up, it would mean that the value itself is a 1, but if you put your finger down, that would mean that the value is a 0, right? So if you have all your fingers
okay. Guys, I think they misinterpreted the question and meant just in like general. If you do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with your fingers, and then just keep on going in a loop. I didn't think they meant. Okay, yeah. Sorry, this question was worded weirdly.
Yeah.
I think it meant to be. I think it meant to be like, what's the highest binary number that you can?
I mean, you can count to 1023 using binary, but like not.
No, like 1023 in binary. Well,
right. Well, 1023 when it's converted to decimal.
To decimal.
Right.
So yeah.
The highest would be 1 in binary.
Yeah.
This question is weird.
Yeah, it's
They
weird.
wouldn't ask you this in AMC.
Right. This is just for fun, right?
Yeah, this is just for fun.
Okay, so how to convert from base 10 to base 2? We
already did this.
Covered it. But yeah. So make sure that you write out the blank like the lines to keep track of
Yeah, it's just the same thing.
Yeah, so to convert 67 to base 2, you would follow these steps. So remember the place values in binary, then you'd pick the place value closest to 62 without going over. So this would be 64 because 128 is bigger than 67. Then you'd subtract 64 from 67 and get a remainder of 3. And now you'd write a 1 in 64th place. Then you find the next place value that fits your number. And 16, 8, and 4 are all too big, so we put zeros in all those places. But 2 fits, so we subtract 2 from 3 and get a remainder of 1, and we write a 1 in the 2's place. So repeat steps 2 and 4 until you reach 1, or you reach 0. In this case, you have to repeat the process one more time. So basically we have already covered this. However, it's good to like know these steps, like not just intuitively, but like know these steps exist, you know? So again, you can write.
I think we can skip over this because we explained it, and I think we did the Jamboard too early.
Right. Okay. So first question, first practice
This
question.
is just extra practice, so just type your answer in the chat.
Yeah, so express 43 in base 2, and make sure you follow the steps. So in the chat, type your answer. I'll give you 2 minutes, so until 10:33. And yeah. And again, if you have any questions,
Okay, so
feel
I've
free to ask.
gotten some private messages. That was very fast, so good job.
Yeah.
That's the speed that you should strive for.
Okay, so my chat isn't pulling up at the moment, so I can't really see any answers. But like, make sure you type your answers in the chat, you know. Make sure you message them to one of us so we know you're participating. If you feel uncomfortable, typing it in the public chat thing.
Yeah, so I've gotten 3 or 4 private messages. So far they've all been right, so that's good.
Yeah. Okay, so it's 10:33, so I'll explain. So following the steps, first find the greatest number that fits into it. So you would get so 32 is the greatest number, the power of 2 that fits into 43. So we'd put a 1 here. 43 minus 32 is equal to 11, right? So 11 is less than 16, so 0 16s will fit into 11. And then 8 is less than 11, so we can have 1 8 in there. 11 minus 8 is equal to 3, and the greatest power of 2 that fits into 3 is 2. So is 2 to the power of 1. So we put a 1 there, and then we put a 0 in the 4's place. And then we have 1 left, so we put a 1 in the 1's place. And you should have gotten 1 0 1 0 1 1. Does anyone
For
have
the most part, those were all the answers I saw, so good
Yeah.
job to everybody that got it right.
Yeah. Okay. So clear all drawings. Okay. So basically this is just the explanation. So yeah. So question 2, express 241 in base 2. Again, remember to like use the place values if that helps you. If it doesn't, feel free to not use them, but like make sure you're somehow keeping track of the numbers you have already looked at.
Okay, so I already got an answer. So that's good.
I think the question might be a bit wrong because the greatest power of 2 that fits into 241 isn't 2 to the power of 6.
That's just the table to like guide you. It is greater, yeah. It's not 2 to the power of 6, but that's just on the screen as like a guide.
Okay, then.
Yeah. Yeah, so I've gotten 1, 2, 3, 4, 5 answers.
I've gotten 2.
Okay, so so far all the answers I've seen are correct.
Yeah, same. Okay, so I have gotten a lot of answers, so like total answers. So I think we should explain now. So okay, so because
Wait, isn't the solution on the next slide?
okay, yeah, it probably
I think that would just be easier because like most of the students already got it now.
yeah. Okay, so
Yeah,
one
so
one
it
one
is, yeah, you guys got it right. So
1 1 1 0 0 0. Okay, sorry. It would be sorry again. Like make sure you do not like it would be 7 6 5 4, and then the 2 to the power of 3 was forgotten, like the place, but you would have a 0 for it. So yeah, the question part was wrong, but yeah, the answer part, sorry. Okay, so the next question.
yeah, you guys need to know subscripts because when you look at the actual AMC question, you're not going to see it written as like 5 base. It's not going to be like 101 base 2. It's going to have a subscript. So it's going to have a 2 in the bottom right-hand corner, and that
Right.
means base. So if
Right.
you ever see that, you know it's base 2. And in our decimal number system, it's not, 10's not written there just because if there's no subscript, that just means it's decimal.
Yeah. Okay, so the question is convert 110111 base 2 to base 10. So again, base 2 is represented with the subscript. And okay, so if you ever have like, if you ever see this notation, you should know it's base 2. And sometimes they do use the word base 2 or base 10 or decimal, right, to represent what you're trying to find or what you're what is given. So those can be used interchangeably. So like, don't think that like base 10 means something different from subscript 10 or decimal. Yeah.
All right, so I've gotten some private messages, some messages in the general chat. So far, they've all looked correct. I've gotten some more private messages. So I've gotten 5 answers so far. So far, they're all correct. So
Yeah.
I think you guys are starting to get the hang of this, and also you're doing it faster. So that's good. The faster you do it, the better.
Right. But then again, if you're getting it wrong and you're doing it quickly, you'd rather be right than do it quickly. So, make sure that you aren't sacrificing your accuracy for time. Okay, so I've gotten 4 answers. So I think I should explain. So basically, 1101011 Yeah. Okay, so this is how you'd write it out in base 2. So basically, the answer is 107 because 2 to the power 6 over here is just 64. Yeah, it's just 64. 64 plus 2 to the power 5 or 32 is equal to 96. And then you add 8 or 2 to the power of 3 and you get 104, and then you add 2 and you you add 2 and you get 106, and then you add 1 and you get 107. So yeah. Okay, So convert 1 0 1 0 1 1 0 to base 2 to base 10. So again, remember that term, that the subscript means base 2. So yeah, and if it helps you any, write out the x to the power of 2, or x to the power of 0, 2 to the power of 0, 2 to the power of 1, so on.
Okay, so I've gotten 3 answers. No, 4. 5. So I think I've seen 1 wrong answer so far.
Oops,
All right, I think we can go over it.
wait, okay. So, okay, wait, sorry, give me a sec. Okay, so 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 6. Okay, so we have 1 0 1 0 1 1 0, right? And basically, we take 2 to the power of 6, and again, that's 64. We add that to 2 to the power of 4, which is 16. We add that to 2 squared and 2 to the 1, which are just 4 and 2 respectively, and we get 86. So
Yeah, all right. Most of you guys got it right.
Yeah.
Next question.
okay, the next one is a challenge question. So should I do it after the break, or should I just?
I think we're gonna do it after the break.
Okay, so everyone, we will be having a we will be having a break right now. Let me just pull it up. Oops. Okay, just pretend you didn't see that. Okay. But yeah, okay, we have a 5-minute break. I will pause the recording.